Hi everyone. This talk is going to take you through what life is like as a GraphQL developer at Yelp. Specifically, I want to take you through some of the tooling and processes we've built to make our lives easier and to ship stuff safer and quicker. So my name is Mark, and I'm a lead on the Client Data API team. So we maintain the GraphQL infrastructure used by the developers at Yelp to build our web and mobile apps. And if you want to get in touch with me about anything I'm about to say, then I'm on Twitter. It's Mark_Larah. Okay, so if you're not familiar with Yelp, it's a place to connect with great local businesses and find where's good to eat, or find plumbers or movers. You can read their reviews, that kind of thing. And here's a typical Yelp business page. And look at all this lovely data that we've pulled from the database. Looks useful, right? Here's what this page looks like without any data, which is not very useful. So I think we can all agree that data is good, and our job is to pipe it into this page somehow. So what I want to do is take you on a journey, and we'll go through the experience together of making a pull request and adding schema for a new feature to our GraphQL service. Along the way, I'll share the processes and tooling we've added for folks so you can get a taste for what our developer experience is like. Now, I want to set the scene and just share the scale of things and why we're invested in spending a lot of time on this. So GraphQL is the modern standard for doing data fetching at Yelp. It's used by hundreds of developers across the org. There are over 500 types in the schema, 500 active persisted queries, so that's queries that are actually being used in production within the last 2 weeks. And as a whole, the GraphQL service gets around 10,000 QPS. So a lot of Yelp depends on this thing running smoothly and efficiently. So yeah, let's see what that looks like. Okay, so let's say we're making a brand new product at Yelp. And there may be some existing schema that you could use, but mostly we're going to have to implement some new backend logic for this. So the first thing we're going to need to figure out is, well, what kind of query do you want to send? What kind of schema do we want? And obviously we don't just want to add the first thing that comes to mind and commit that. Bad schema choices can be costly and hard to remove once they're used in prod, so we want to keep things fairly flexible up until the point that we actually commit the code. Now, maybe you're new to the company or new to GraphQL, and you haven't quite yet got a feel for what's in the rest of the schema or what idiomatic schema looks like in general. And so when writing out the query for your new page, we encourage developers to just write out a thing that looks like a GraphQL query and does the thing that you want. And we call this the dream query. And that's the query that you wished you could write if the schema was magically available to power it. And from there, we have a cross-org group of schema reviewers who can help review and point to existing types and such. And we found this to be a good way of communicating things and onboarding folks in a less intimidating manner. I've linked to our blog post which describes this process in more detail and why we like it. Go check it out, the link in the slide. So yeah, let's go ahead with our new feature, and we've written a dream query that we want to use on our new web page. And once we've got something that we're reasonably happy with and looks good on paper, so next we can start to hammer out the schema that we'd write to power that query. And I guess really this can be done in parallel with the dream query. We're a big fan of an open source tool called GraphQL Faker. It's a bit like Graphical or GraphQL Playground, and it spins up an IDE for you to make queries in. But you also get an editor to add new schema and new types on the fly. So you can query them and get auto-generated lorem ipsum data back. And this can also plug into and extend an existing schema. So we use this to extend our real GraphQL schema, and you can make queries that combine real schema and your new work in progress schema. And this is a really great way to have a quick iteration loop set up and get a feel for the new schema you want to add before actually spending time implementing the resolvers. We've made this globally available on our developer machines, so you just type in one command and you spin up a GraphQL Faker instance pre-configured to talk to one of our real dev instances of GraphQL, and it's all magically available. And you could go even further with this and actually plug this into the React app you're developing and try it out with some real components you're developing in the UI in tandem, so you don't have to wait for the backend. So this is great for parallelizing work between backend and front-end devs. GraphQL Faker is great. I highly recommend using it in your development workflows and providing some light tooling around it so it's easy to extend your real schema and use it in your React apps. Okay, so we're very happy with our new schema and we want to invest some time in making it work for realsies and implementing the resolvers. Quick architecture snapshot. This is a rough overview of what our architecture looks like. Hopefully it looks kind of familiar. We just have a bunch of different services owned by different teams that expose internal REST APIs for various products and use cases. We talk to all of these services through GraphQL Gateway Service, which is our slightly monolithic GraphQL service written in Node with Apollo Server. And resolvers need to fetch data and talk to those endpoints. And there's some common problems here, like how do we avoid blowing up the backend and making a bunch of extra wasted unnecessary network requests? Like how do you properly utilize bulk endpoints? And the main answer is data loaders. Apollo also has a pattern called data sources. I'm sure most of you probably already know about data loaders. It exists in a few languages, but if not, the TLDR here is that they're a magic batching and caching function over some underlying resource. If you don't have direct access to where the data lives in your GraphQL server and you need to connect to some external resource, then you probably should be using something like this. Okay, so we use data loaders. But as with many things in software and open source tooling, you get some basic examples in the docs and some tutorials online, but it gets tricky when we want to scale this thing up and plug it into the rest of Yelp. The issue is that we have hundreds of these internal HTTP endpoints that are distributed across hundreds of services. And the vanilla approach might be to write the hundreds of data loaders by hand to talk to all these hundreds of endpoints. And this would be pretty gross for a bunch of reasons. We have multiple endpoints that return user information. For example, there's many different representations of user. So if someone made a user data loader, what endpoint does it go to? Who decides? How do we stop people making multiple user data loaders? How do we get typing on these data loaders? How do we ensure that we get the error handling and the logging correct each time? It just takes time to write. It's another thing to maintain, etc. So anyway, you can imagine that all of this inconsistent boilerplate might get pretty yucky to deal with. The solution that we came up with was a cogen layer imaginatively named Data Loader Cogen. We already have Swagger UI set up to document all of the internal endpoints across Yelp. And folks are already pretty used to thinking in terms of these Swagger endpoints and their interfaces. They're very widely used and very well documented, just a good source of truth. And we want people to think in terms of those endpoints. And this is what Data Loader Cogen does. So we have a big config file and it generates data loaders for every endpoint that we specify. So you think in terms of the endpoints, not data loaders, which might have subtle differences. And we have this strict one-to-one mapping, so there's no need to think about, well, which data loader do I need for this endpoint? There'll just always be the one true one, and it will have kind of a matching interface. And this is great. So the data loader layer is basically now transparent. It's one less thing to worry about. It saves a bunch of time writing them and maintaining them, and has allowed us to scale up to having hundreds of data loaders, all with the exact same error handling and logging, etc. Even if you're not talking to REST endpoints behind the scenes, some of these concepts may still apply to your situation. I think the takeaway here is that cogen and removing human-maintained things where possible is good. So anyway, we open source this, and if you're interested in learning more about it, you can check it out on GitHub with the link in the slide. Another thing that I highly recommend is generated types for resolvers. We just use a really good library from the Guild, GraphQL code generator, which does a bunch of other things as well, but we use it to generate types from our schema file, and we use that to type check the JavaScript implementation. So that's just like a nice, easy, quick win. Okay, so now we're really ready to commit to our new schema by committing the code. And we use Precommits as an early warning system for things that would break the build. So Precommit is a tool that performs checks just after you type git commit in your terminal, but before it actually gets committed. And this is mostly for things like linters and type checkers and stuff that runs in CI, but this runs in your terminal immediately, so you don't have to wait 20 minutes for CI to fail and then realize, oh, I had some white space bug. Aside from linting the JavaScript, we also lint the schema. And to do this, we use a tool called GraphQL Schema Linter. And this lets us check against a basic set of naming conventions and style rules. And yeah, it's a really good tool. And we run it in Precommit. So this is what happens if you try and sneak through some schema that we know for sure breaks the rules. All right, assuming everything went well, now it's time to send your pull request. And the first thing we do is have a couple of GitHub bots to check more of your schema. The first one is Schema Check Bot, and this uses a package called GraphQL Inspector to detect any breaking changes to the schema. If we find any breaking changes, so things like removing a field or renaming a field, then we show a big warning sign like this. And we go a step beyond this, and so we have this allow list of queries, persisted queries, and we know when queries are being used, and we can go through all of the queries that are being used in the last 2 weeks and say, hey, it looks like you're trying to remove this field, but we have like these 20 queries that are using this field in prod at the moment, so it's going to break these queries, so maybe don't push this. So that's a good warning system and stops us from breaking Yelp. Like the PR will actually go red and you can't push it. And on the flip side, if you really do want to remove a field after a proper deprecation process, or you're cleaning up some experiment stuff, then we can say, the logic says, okay, well, you're removing a field, but we didn't actually find any documents that were being used in prod that uses this field, so it's not going to break anything, you're good to go, and then the GitHub check just passes for you. Another bot that UA on our team is currently working on is Schema Suggestions bot. And so this is for things that we think might apply to you, but they're inherently hard to strictly lint against. And so we don't want to fail the build on these. And this could be stuff like, hey, you're adding a new type called business hours, but it looks like there's already a type called business opening hours. So maybe do you want to use that instead? And we just have a bunch of fancy regex rules to sniff for stuff that may be breaking our schema design guidelines. So if we think that we found something, then you'll see an inline GitHub comment and you can choose to do something about it or ignore it as a false positive. Once everything looks good, the final step is to get approval from someone in our schema review group. And these are folks that are familiar with our schema design guidelines, and this step exists as a final extra safety check to make sure that the schema looks good. Initially, this was just a small handful of devs to make sure that we had consistency in the first few types and seed that knowledge across the company, but now it's open to everyone, and it's a learning module that we ask people to go through, and then once they've completed it, they can join the group and approve new schema. And we try and aim for 2 reviewers per team, but it is uneven in places, and so we have folks handle reviews from different teams where necessary, and that's a good thing as well, because it means there's no kind of like team specific opinions about schema, and everything kind of looks a bit more consistent across the company. Okay, one final thing I wanted to mention was the value of strong documentation. In the first year that we were rolling out GraphQL, I'd say it was an absolutely even split of time spent on coding versus the internal documentation to bootstrap knowledge of this new thing and serve as onboarding material. For a platform that many developers are going to use over time, the docs are just as much of a product that is a focus, and honestly, just the documentation and the thought and process that goes into it could be a talk in itself, but that's not the most gripping subject matter, so that's the subject for another talk. The only big takeaways I'll give here are that most of the time, product people just want to focus on building products, and for infra stuff, just want to see things to copy and paste and not have to think about it from first principles. And the whole thing you see in open source sometimes of we're unopinionated, use X however you want, is great for open source where the authors don't know your specific setup, but internally at the company we do know your setup, and it's our job as an infra team to have those opinions and to create abstractions and set guidelines as much as possible to save everyone else at the company time having to do that and doing it a million different ways. So having all that listed in the docs of just do this, we found that to work for us. I'm kind of excited to say that just this week we open sourced some of the pages related to schema design. So you can go check it out on GitHub with the link on the slide to see how we do schema design at Yelp. Finally, if you think that we missed anything that we should be doing, then great, we'd love to hear from you. We are hiring, so go check out the careers page. And yeah, that's all I have. Thanks, everyone.